We shouted our friend Phil, who demoed the Fronius TransSteel 5000 for a customer, and we were impressed. So if you're thinking of grabbing one before they're gone forever, keep watching. Don't forget to like and subscribe.
Onto the wire. Sorry, what do you mean? So typically, right, when we feed wire out the first time, we feed wire out the front. When the wire's poking out of our feeder, we slip this on, right? So our system here, the way we do our liners, everything is set up in a certain way where there is no gap, there is no possibility for that wire to misfeed in the wrong direction, right? We also have what's called comfort stop. So right now our ground's connected, and as I bring this wire out and it makes a short circuit ground connection, it stops feeding. My hand is still on the button. So it's a safety feature, right? Plate thickness, right? So we got, looks to be about 200 thou, maybe a little less, right? On here, this is how the system works essentially. We have everything selected. We're running in standard synergic. So as I change my wire feed speed, my voltage automatically adjusts. These three and voltage are tied together, right? So we have wire feed speed, plate thickness, and amperage. Then we have voltage, we have our inductance, and then we have arc length. So arc length is our voltage adjustment now. I'm gonna go to wire feed speed, I'm gonna go to plate thickness. This is around 180 to 200 thou, I'm just eyeballing it. So our arc length adjustment is not an integer, like a value for value. So essentially our voltage, right? And as we adjust our arc length, we have the option to go up to 30, plus 30, or minus 30. So that doesn't represent anything, it's just a scale, essentially, right? Right? I don't want to hear any spatters.
When you hear that, it's almost like there's like lack of gas flow in those little areas.
We're right in that range where we're flirting with globular, right? So it's not going to run as smooth as if we were further out and spray on thicker plate. So we're going to switch over to pulse. So now, select our plate thickness, we're going to go down 200, try again. Same settings, I'm not going to change anything, right? So we're at the same settings, but we're in a pulse transfer now. Go ahead, light up, tell me what you think. It sounds different. Yeah, it'll be a little foreign, okay? It sounds like an angry bee. Now we still have the same capacity to make all the changes we would traditionally do. I can still change my voltage, I can still change everything else. So we go to our arc length, and I usually say play in a factor of plus 10 or minus 10 is usually a good starting point.
When you're changing the arc length, is that in return changing the voltage?
Yes, so your voltage is now your arc length essentially with our system, right? So we will go to 23.6. So how about this? We're gonna start at 0, and I'm gonna shorten this up as you weld. And we'll hear it and see what you're looking for, right? Yep. How's that? That's as cold as I'd want to go. To me, this is really cold. Yeah. Okay, and you're starting to see that with spatter. Yeah. So if I were running this, I would honestly probably run closer to say 175. So that's probably around 200, give or take. Try that. How do you like that?
Yeah. I could hear that humming. Kind of went down in pitch a little bit, but then it got a lot more stable.
Yeah, yeah.
You know what I'm trying to say?
Yeah. Here's the thing that this machine can do that most machines on the market can't do, other than our other stuff. We can change our droplet frequency, which means we can change our arc pressure essentially, right? I won't go too much into the science just to save time, but essentially we're changing that droplet rate, slowing it down or speeding it up. Think of it like the same amount of deposition comes out. So if you speed up the droplet rate, there's more force, acts like a spear, it digs in further. If you reduce your droplet rate, the droplets get larger, acts more like a hammer, doesn't dig down as much.
It's like arc force.
Exactly, exactly. So we're going to start, if you want, on the back side of this, on this plate. We'll start at one end. We're going to start at the very negative, so that's going to be a very high arc pressure, and then we're going to lighten it up as you go, okay? Yeah, exactly. And then I'll swing it back. And you can hear the pitch change. Right? So it just gives you a little bit more control over your pulse. If you find it a little too hot or a little too cold, as experienced welders, we know ambient temperature, condition of the plate, condition of the wire, the position you're in, all this is a factor, right? So you still need to be able to change your voltage. And we don't want to take that away from an experienced welder. This is a great starting point. From there, you adjust your arc length.
And then you can save settings too, right?
Yeah, so we have five presets on the front here. So to save one, you just hold, program, boom, it's saved in. So now if I can move around, so if I wanted to switch over to say standard synergic, right? Or say stick welding, you could even stick weld, right? And then you just, I want to switch back to pulse, boom. Anytime you could do anything with any other system, you can do with this, and then some. So would you spray, full-on spray, vertical up with this? No. There are methods to do certain things at higher power ranges out of positions that other machines typically can't do with something called Synchropulse. So what I'm going to do is I'm going to go to my material thickness. So 1/8 inch is around 125 thou, give or take. Change all my settings back to factory 0. 0 on your dynamic, 0 on your arc length. This is where the system says, hey, you should have a good weld here, okay? Now I'm going to turn on Synchropulse. So Synchropulse is what you might know of as pulse on pulse. So if I want to weld out of position, this is a great addition to that, right? We have a second layer of adjustment. So there's only one main background menu. I'm going to scroll till I see an F. I passed it, so right now it's off. This stands for frequency. So I'm going to go about a 1.1, and then the next is our delta. So what we're doing is we're undulating our wire feed speed, okay, back and forth at a frequency of 1.2 right now. So usually I say a delta, 75 is good. It's a good for what we're doing. And then the next thing is we have a secondary arc length, because now we have arc length in the high and the low, and we might make an adjustment on that, we might not. We'll see. So now we have Synchropulse on. Now this is going to sound very foreign and unlike anything you've ever seen before. It sounds like a London ambulance a little bit. So I'll go ahead and tack this up. I'll run a bead. Okay, here we go. So, settings are a little bit off. I think we have a little bit too much wire. So I'm going to droop that down a little bit. I'm also going to change the arc length just slightly until we get a frequency that I'm happy with and a setting I'm happy with. Now on this thin stuff, you could also weld downhill too. So now we have a little bit too much spatter. Sounds like it's in the other range. So just want to get it to its perfect, basically, right? And then once you have it, you can save it. All I'm kind of happy with that. So it's a great, and what this does too is it also lowers heat input drastically. So another thing you can do is you can up the frequency. So what we can do is we go in here. So what I did is I just maxed it out at 5 hertz. You're going to hear the difference right away. So go ahead. Yeah. I'm going to give it more power. All right. So essentially what we've done there is we've mitigated the heat input, right? So on stainlesses, that kind of effect is quite nice. So I was running a little, you know, a little cold there. I probably would have changed the arc length in the other background menu if I had time, but yeah, it's just more control, right? This comes especially handy in aluminum. So we don't run 035 aluminum wire, typically. We just find it doesn't run great, so we just stay away. We know it has feeding issues. Oops. We don't really get bird nesting, so we don't really have a feature to detect it. I've run, out of all our machines, I've run many aluminum seams. And I think I've had a grand total of 2 bird's nests ever. And the first one was my second day and I didn't know how to configure the system. And the other one was because I forgot to put a tippet. So it's both times operator error. If the system's configured properly, you won't get a bird's nest on aluminum. So we are first going to weld without Synchropulse just to demonstrate what you might see traditionally, right? So we're going to weld in a pulse synergic fashion. Typically, I'm always going to say stay in pulse. Even on steel, I would always say stay on pulse. Now there's certain times where you might want to be in CV on steel, but getting into semantics, right? So I'm aluminum welding, right? So that's about, again, around an 1/8 inch. So that's about 125 thou. If you knew your wire feed speed, you could just set your wire feed speed. It's all whatever you want. You can go by voltage. You can change the voltage here, which will change your wire feed speed, right? You can also go by your amps. Say you have to weld at a certain amperage. You can change it by your amperage. Plate thickness is nice and easy and simple. 125 thou, 1/8 inch. So then, we're gonna make sure our other values are zeroed out. Lower our arc length.
It's running in AC current now?
No. So there's only one system that I know of in the world that can weld, that I know of, that can weld on AC for MIG welding, and that's our I-Wave.
Okay. So MIG welding.
MIG welding is just still DC, right? Yeah. So there is certain, the I-Wave is capable of running an AC MIG, which is something pretty spectacular. It gives you the cleaning action to TIG, also drastically reduces heat input, so you can actually MIG weld the thin wall of a pop can.
Wow.
Yeah. So, as of course CMT technology too. So, okay, so we're on pulse now. Because we're welding on aluminum, what's aluminum very susceptible to when you end your weld? Crater, exactly. So we want a crater fill option, right, to stop from crater cracking, because the thermal conductivity of aluminum just pulls that heat away from the weld, right? Yeah, so we're gonna go in and we're gonna put some settings for our hot start and cold start. So here we have gas pre-flow, gas post-flow. We have our slope. So a slope is how long it takes to get from your starting current to your operating current and then back down to your end current.
Okay.
So you can go, basically, if you ever have what's called wishboning, fishtailing, weld necking, there's a lot of different terms in the industry, urban slang, I guess. But if the start of your weld or the end of your weld is too big compared to your actual pass, then you can increase your slope time to kind of smooth that out a little bit, right? So we'll keep it at 1 second for now. This would be our start amperage, or our start current, sorry. So it would be 130% of our value. Right? So we have 30% more power to break through that oxide layer, because aluminum oxide melts at a much higher temperature than the aluminum underneath, right? So then we go to our end current, 50% to cool it down a little bit. Now you can play around with this. You go 50, maybe go a little longer on the end time, or sorry, go 30 and make it less. You play around with it. So we'll try 50.
But again, that first, when you went and first set the 8-inch material, the settings, like everything should be relative
for a good bead. This is all your starts and stops. This takes effect across the board no matter what power level you're at.
So once you set that, it's going to be only for the aluminum setting, or it's going to be for everything?
It's going to be for trigger settings. Now, it's still fine to use on steel. I will say that you can run this on steel, and if anything, it's like good hot start, good crater fill, right? There's nothing wrong with having that kind of stuff on steel. But in this case, it is a trigger function mode. So we're going to go on special 4-step, which will activate these parameters so that
You're not on that.
I will be when we come out. Yeah. So I'll just continue here. So end current is 50%. Start time. So I'm going to say for about half a second, you're going to have that 130%. And then our end time, I'm going to say probably about 0.7. I find is usually around a good number. Okay. And that's it. See, ours is on the hood. That's nice. Special 4-step is a slightly different modification. It is like a toggle, but we have more control on the hot start and the crater fill. Okay. Now, if we activate the times on the hot start and the crater fill, then we have this in traditional 2T mode. So you can run aluminum on 2T, right? So you are doing your hold trigger like you're used to. Most welders do that, especially on shorter seams, right? And now we have that hot start and crater fill. So when I go to start, I'm going to pull the trigger. There's a timed hot start, and then when I get to the end of my weld, when I let go, it's going to give you the fill. So let it do its thing at the end, right? So I'm going to start a pass. This is around, we already have the settings set. So I'm just going to run a small bead. So for me, that's too cold. We need more wire. It's a beautiful weld.
Pull the trigger and point, eh?
Yep, just like you traditionally would. Just keep an eye out for that crater fill.
Can you blend that into there, into the crater?
You can set it a little bit more, yeah, if you wanted to. Now, so you could change the hot start so that you have a hotter start to blow out that end that you had, or you could lessen your end so you don't have as much of an end, right? You have options.
Yeah, but even like, I guess I got a bit of a crater there, but you could come back in and fill that and keep going.
Yeah, so if you want, kick on, go into that crater, go away, and when you let go of that trigger, really just hold there for a second, right? Don't keep going. So it's great for terminating a weld, right?
Yeah, that's nice.
Pretty good. Like this one here was a tad slow, but that's pretty good.
Yeah.
So the necking here, so I can see that there's a bit too much of a thick weld at the start. So what I might do is I might lower my hot start a little bit, right?
Well, I also went back into that crater too. So
Yeah.
Probably deposited some material that went back and went over that material again.
Yeah, so what I'm gonna do here is I'm gonna have the start the current, because current is a mixture of your wire feed speed and your voltage, right? So I'm going to lower it just slightly.
And you're in pulse right now, right?
Yep, correct. So we do vertical up here. So I'm going to run colder. Now this is without Synchropulse. I'll show you Synchropulse after. So a little bit underpowered. The other thing I recommend doing too, so this is our Tough Gun style for TransSteel. There's another type of MIG gun we have, our up-down torch, which has up-down right on the torch, so you can increase your power so you don't have to go back to the welder. You can also do it mid-weld. If you're like, I don't have enough power, click, 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 and you get a little bit more, right? So I'm just gonna increase that wire feed speed just a little bit. Easy as pie.
Yeah, that's beautiful.
Want to give it a go?
That's so easy. Yeah, I'll try.
Oh, it's easy.
Yeah, I think you're just running it straight.
Yeah, just run it straight. You're natural.
How many people come to me for repairs on aluminum, and I can say I can't do it?
Yep. This system, that's what we're known for.
That push-pull guy doesn't take 4 hours to set it up.
We are known for our aluminum. Because it knows it's welding aluminum, and we tell it we're welding 1/8" plate, it knows, okay, I'm welding aluminum, and it's gonna be an 1/8 of an inch thick. So it spits out your wire feed speed and your voltage for you. So no guesswork, right? The other thing you can do is you could run aluminum specifically on Special 4T. Special 4T is a little bit more involved, but basically it's a toggle, so click on, click off, but instead of clicking, you hold. So as you hold, you get your hot start. And as long as you hold it, you have your hot start. When you let go, it dies down to your operating current. And then when you want your crater fill, you hold the trigger again. And then as long as you're holding your crater fill, it goes down to your end crater percentage. And you have full control.
And you set that on S4T, and then when you go to
2T, it's just regular old
When you
2T.
go to steel, go to 2T,
Yeah.
and then run that.
So there's like 3 different options for you right there that you can configure and configure it how you like, right? So now the last treat on aluminum, I gotta show you Synchropulse because that's what everybody wants to see. So we're gonna go back into our background. It's very easy. There's not too much in the background. There's like 10 settings essentially. It's one background. So you don't have a whole lot to worry about. But I'm gonna find my frequency. I'm gonna go to like a 1.2, a delta of about maybe 75, and then arc length I'm gonna leave, a little bit high. And that's it. So now I'm gonna go in and we're gonna just tack up a couple plates again. Close to it. We do have processes such as ripple drive on the TPSI, so on our other systems that put down a weld, and an experienced welder will look at that and go, that's a TIG weld, and it's not. We have that capability. We have the technology to be able to do MIG welds that look like TIG welds, that pass testing, all sorts of things. It's amazing. It's an amazing process. I did some yesterday, actually. It's like AI, yeah. It's almost, you look at it and you think it's fake. It's that good. A little bit more power.
That's sick.
Just a standard push gun. So it's a little, I notice your travel speed, okay? So your travel speed is a little fast. That's okay though, because we can configure the system to match your travel speed. So what I'll do is, I'll go into the system. So what you're gonna see is that frequency is gonna be faster. So I want you to just do a smooth travel. You might slow it down a little bit, just a touch, but you'll be fine. So you can see here the heat saturation, right, is starting to take an effect. So that weld at the start was like great, and then we had a little bit of a washout, right, because it's getting up there in heat. So the last thing I'm going to show you, because we can do it with this. Perfect. So now I'm gonna, for out of position stuff, I'm gonna go a little bit slower, probably about 1.3. And the delta, I'm gonna lower a little bit.
Kind of just second nature, right?
Second nature, yeah. You'll understand once you play around with Synchropulse, you'll get familiar with it. And the training that we give is very thorough. We train you not just on the system, but just on MIG training in general, right? Like spray transfer, different effects, all that kind of stuff. When we're done training you, you know just as much as we do on the system. So you're very comfortable with it. You'll get a feel for it. Yeah, so
I mean, for the first time touching this thing.
exactly. I was just going to bring that up. How often have you gotten a new machine that you're not used to, that it can take you days to start getting like even a good bead, right? Yeah. So here we've just stuck in our plate thickness, and Synchropulse of course helps, but even on your beads before, running vertical up, it was no problem. And we didn't even touch on the last, which is interval welding. So you can even run, instead of Synchropulse, you can run interval welding, which can give you like an arc on, arc off appearance, and you can get a little bit closer to a TIG appearance as well with that. But I like Synchropulse. Synchropulse is easy to set up, it's quick, it's efficient, and it works really well.
Cool.